Hello and welcome. My name is Will Connolly, and this is going to be my video tutorial. We are going to be covering the equation, the integral of parentheses 3x plus x squared, close parentheses, sine of x dx. We are going to be using integration by parts, because what else would we be using? First, let's review the formula. The integral of u dv equals u times v minus the integral of v du, and we use Lie. And using Lie, we can see that this term is algebraic versus this term is trigonometric. So we're going to take the derivative of the algebraic term and integrate the trigonometric term. So let's get integrating. So first our uv, which is going to be, it's kind of hard to not block the thing I'm trying to write. Let's see if this works. Plus 3x. Now we're going to take dv. Not dv, regular v, which means we need to take sine of x over here and integrate it. Now, I guess I'm going to squeeze in an x there. We all know that the integral of the sine of x is negative cosine of x, because the derivative of negative cosine of x gets you regular sine of x, which means times negative cosine of x. Bam. Now we have the second term. And if Mr. Shore is the only person watching this, he's going to see the problem with the second term, but it's going to be apparent pretty quickly. Let's see. So our v term, which is now negative cosine of x, because sine of x is just dv. So let's get this over here. Negative cosine of x times du. Du is just the derivative of this, which is 2x plus, there we go, camera's over here, 2x plus 3. I don't think we can integrate this with Calc 1 math, which means this is a double problem, because now we get to use integration by parts on this. So I'm just going to move over here to this unused side of the page, box it off, and we're going to do another integration by parts problem in the middle of our integration by parts problem. I planned it out, so hopefully this will be enough space. If not, we're going to add more. So the integral, and we have to remember there's a negative sign in front of it, and we'll get back to that negative sign, but it's negative, there we go. Negative cosine x times 2x plus 3 dx. And again, we're going to go back to Lie, or L-I-A-T-E. I don't know if it's actually called Lie. This is trigonometric, this is algebraic. Same deal as before. This is our u, and this is our v. So we're going to take our u first and just put it down. 2x plus 3. Our v, the integral of negative cosine of x, is just going to be negative sine of x, because the derivative of negative sine of x is going to get us negative cosine of x. Yeah, I didn't give myself enough room here. That is so awkward. So we're just going to have a minus sign here for our second integral. But you're going to notice this integral is not going to be as bad, because it simplifies down to v du, which means it's negative sine of x, in parentheses there, multiplied by the derivative of 2x plus 3, which, thankfully for all of us, is 2. This means that we get, if we distribute the negative sign, which is negative 2x sine of x plus 3, actually I guess that's plus a negative 3, we're just going to put that negative in there, plus negative 3 sine of x minus, and then we're going to have the second line for the integral. So the integral of negative sine is cosine. And then there's just going to be a 2 in front of it. But the thing is, because it's minus that, it's actually just going to be negative 2 minus 2 cosine x. And there we go. And that is the mini integration by parts in this big integration by parts problem. But now we're going to go back to our actual equation. We now know this integral. There's a negative sign in front of it, which means we're going to have to flip all these signs. Also, I got to remember this is a negative sign. But we're going to distribute the negative cosine x. X squared plus, put the x squared on the wrong side, that's my bad, plus a negative, I messed that one up too. There are a lot of negatives in this one, and I seem to be catching none of them on the first try. And then we're going to do minus, and now, it's because we already did this integral over here, we're going to do minus negative 2x sine of x minus 3 sine of x minus 2 cosine x. And there we go. It's a little smushed at the edge of the page there. But all these negatives are going to become positives because we're distributing this negative sign. So now we're going to go negative. We're going to put the x squared on the right side of this one, cosine of x, minus 3x cosine of x, plus 2x sine of x, and then we're going to add a plus 3 sine of x plus 2, we're running out of room at the edge of here, we're just going to go on to the next line, plus 2, and that was cosine of x. So here's our big scary equation, and because now we've cleaned up all the integrals, just to remember that whenever you integrate an indefinite integral, you have a constant of integration. It doesn't matter when you add it, as long as it's before the end of the problem. It can be positive or negative, so it doesn't matter what the sign is, but I always like to go positive. And now we're just going to clean this up. And we're going to move it over so I have a bit more room, and we're going to put the cosines and sines together. Negative x cosine x minus 3x cosine x. Let's see. So plus 2x. Actually, no, there's a plus 2 cosine of x. Sadly, that can't combine with any of these because they're not like terms. Then we're going to have plus 2x sine of x plus 3 sine of x plus c. We're just going to get that right on the edge of the page. It's a very awful c. Sorry, apologies about that. We're going to box our answer. And there you go. 2 for the price of 1. If I can focus in on the answer, we started with the integral of 3x plus x squared in parentheses sine x dx. And after 2 integrations by parts, we have negative x squared cosine of x minus 3x cosine of x plus 2 cosine of x plus 2x sine of x plus 3 sine of x plus c. I hope you enjoyed. Here's all the work we did. Have a good day.